Let's see this question. We're given 3 equations. So we have a system of 3 equations. The first one, we have xy plus z equals 40. Second one, xz plus y equals 51. Then the sum of 3 two variables adds up to be 19. So if we add this to the first two, we see these two shares common factor of x. So once we factor out x, we have y plus z. And of course, this is y plus z. Then we can put this in a factored form. Okay, let's do that. So we add those 2 equations. So xy plus xz plus z plus y equals 40 plus 51, which is 91. Now these two shares common factor of x. So factor of x, y plus z plus, now we're treating this one as one group. So z plus y is the same as y plus z. Now we're thinking this as 1 multiplied by this, right? Because these two groups we shares common factor of y plus z. So let's factor out y plus z. Then the first group will have x left. The second group will have 1 plus 1. So that equals to 91. What's good about this? What's good about this is that we can use the third equation. The third equation, so if we minus x on both sides, here we say y plus z equals to 19 minus x. So let's do that. So y plus z now is 19 minus x. Now we have a quadratic equation to solve, right? So we FOIL it. What double distribution? 19 times x is 19x, negative x times 1, negative x, 19x minus x, that's 18x. Then we have negative x times x, negative x squared. Then 19 times 1, positive 19. Now we move negative 91 to the left-hand side, it becomes negative. Then equals 0, right? That's how we solve quadratic equation. We try to put in a factored form. So we leave the right-hand side to be 0. Now let's simplify this. So we get negative x squared plus 18x. Subtract those two. So 19 minus 91 is 91 negative 91 minus 19, which is 72, minus 72. Right, because 72 plus 19 is 91. Now let's multiply by negative 1. Let's multiply by negative 1 with every term in the equation. So we change the leading term x squared to be positive. Now 18x becomes negative. Negative 72 becomes positive 72. Well, 0 is still 0. 0 times anything will be 0. So we want 2 solutions to 2 factors adds up to be negative 18, but multiply to be 72. Right? 12 times 6, right? Because 12 plus 6 or negative in negative 12 plus negative 6, that's negative 18. And negative 12 times negative 6, indeed, that's positive 72. All right, so we can put in the factor form as x minus 12, x minus 6 equals 0. So by 0 property, we get x minus 12 equals 0. That's x equals 12. Or x minus 6 can be 0. X equals 6. So we have 2 solutions for x. Well, let's see the first one. When x equals 12, this equation becomes y plus z equals to 19 minus 12, which is 7. So y plus z equals to 7. So we need another one. Okay, so let's just pick one from this. Let's pick the first one to work with because we know x value now. So x is 12, so I have 12y plus z equals to 40. Now I have 2 variables, 2 equations, guaranteed solvable. So what do? We subtract. Let's subtract those 2 equations. So we use 12y, subtract y, we get 11y. Z minus z equals 0. 40 minus 7, 33. So divided by 11 on both sides, so y equals 3. Now y equals 3, y plus z equals 7, so z equals to 4. So the 4 plus 3 equals 7. So that's the first solution. So first solution, x, y, z, we have 12, 3, 4 as one solution. Second, x can be 6. Right? If x is 6, y plus z is 19 minus 6, which is 13. Now we can use the first equation or second equation, doesn't matter. Let's try to use the second equation. So we use every one. So I have 12z plus y equals to 51, right? We subtract again the two equations, 12z minus z, we get 11z. Y minus y becomes 0. Now equals to 51, subtract 13. That's 51 subtract 13. That's a 4. So no, that's 3. 37. No, I mean 38. Right? Because a plus 3 is 1, 11. Then yes, okay, so z is not a whole number. So z equals to 38 divided by 11. That looks strange, but anyway. So now we have z. So once we have z, we can solve for y. Let me see if I made a mistake. So when x equals 6, y plus z equals 19 minus 6, which is 13. Then we use the second equation. We have 12 times z. Oh no! Oh, I made a mistake. I made a mistake. Because x equals 6, but I'm still using 12. I'm still using the first x value. So this is a 6. All right. Okay, so we get a 6z because the x is a 6 now. 6z plus y equals 51. Now 6z minus z, that's 5z, not 11z. So 51 minus, right, y minus y is 0. 6z plus y equals to 51. Right? Okay, 6z minus z, that's 5z. Y minus y, that's 0. 51 minus 13, that's 38. Because 38 plus 13 is a 51. Well, we still get not a whole number, I get a fraction. Okay, anyway. So y equals to 7. So y plus z equals 13. Y equals 13 minus 38 over 5. Right? 13 will continue to be 13 times 5. Then minus 38 divided by 5. Well, that's 65. 13 times 5, 65. 65 minus 38 divided by 5. Or 65, that's 27. All right, so the second solution is x equals 6, y equals to 27 over 5, z equals to 38 over 5. Okay, you may check them to see if I have made a mistake. All right, that's it. So we have two sets of solutions for this.